All right, so today we're going to get into molar mass. We've been talking about the mole recently, and so we're going to, instead of going to particles, because we can't really measure particles or moles in a lab setting, we need something that we can actually measure, and that's where we get mass. We can definitely measure mass in a lab, and so then we can get numbers that we can use using a balance. So what is molar mass? Molar mass is the mass of 1 mole of a substance. So if I had a mole, which is Avogadro's number, which is 6.02 times 10 to the 23rd of any substance, and I took its mass, that would be the molar mass of that substance. It has a lot of different names, and depending on what type of formula it is and things like that, sometimes it's called formula mass, sometimes it's called gram formula mass, sometimes it's called molecular mass. There's a lot of different names, but they basically all mean the same thing with a few minor hiccups or distinctions. And the way we find it is we use the atomic masses for the elements on the periodic table. So since we already have the mass of each of the elements, we are just simply going to add up the masses of each element in the formula to get our molar mass. Okay, so we're going to do a couple examples. I'm going to show you how I want you to do these. So the way that I want you to do it is when you have your compound, so this is potassium chloride, KCl, draw a line under it and then write out what elements you have. So in this case we have K and Cl. Okay. So the molar mass for K, or the atomic mass, is 39.098. And I'd like you to round to the hundredths. So 098 would be 39.10, 2 places after the decimal. And then over here, chlorine is over here, 35.45 for its mass. So once you get here, we're simply going to add these together. So this is 5, 5, 14, 74.55, and the unit is grams per mole. So G/mol is the unit. Okay, so for each one of these, this is how I want you to set it up. All right. Now, what about if we have subscripts, like in H2SO4, sulfuric acid? So again, I want you to draw a line underneath. We have H, S, and O. Hydrogen 1.01. From, if you look at the periodic table, it's 1.008, which would round, if we're rounding to the hundredths, 1.01. Sulfur is, I know it's hard to get it to focus on something so small. Maybe if I can. So sulfur is 32.066, which would be 32.07. Refocus it down there. 32.07, and then oxygen is 16. It's 15.999, which can round to 16. So we have 2 hydrogens. So I'm going to multiply, when I have a subscript, I'm going to multiply those numbers by their mass. So I have 2 hydrogens, each one's 1.01, so that would give me 2.02. Oxygen is 16, and I have 4 of those. So I'm going to do, that would be 64. Okay. So then I add these up. The 2.02, the 32.07, I'm going to bring the 32.07 over here so it's a little easier to add. So that would be 90, it's 96, 98. So 98.09 grams per mole. Okay. Again, we're just simply taking the numbers from the periodic table and then adding them together. It's the sum of those. Okay. All right, now the last one, iron 3 hydroxide. So we have Fe, we have O, we have H, Fe is 55.85 from your periodic table. It's right here, 55.85. Oxygen is 16. Hydrogen is 1.01. Okay. And again, as we do these more and more, you'll kind of start memorizing them because we use oxygen and hydrogen quite a bit. And remember this 3, if it's outside the parentheses, it goes to both of those. So we have 3 oxygens and 3 hydrogens. So 16 times 3, that's 48. Hydrogen, 1.01 times 3 is 3.03. So then we're going to have, if we add them up, we have 55.85 plus 48 plus 3.03. So we got 88, 51, 56, what is that, 106.8, 88 grams per mole. Okay. All right, so that is the basics of how you do that. It's not all that difficult, hopefully. Just make sure you're using your periodic table. All right, let me know if you have any questions.